Hello everyone, myself I am Saranya, working as an assistant professor in MLR Institute of Technology in the Department of AIML. Today I am going to discuss about the topic of block cipher design principles, stream cipher and RC4. It is nothing but an reversed cipher 4 we are going to discuss in this video. So coming to the topics, we are going to discuss what is meant by block cipher and its principles, and what is the stream cipher and what are those examples, and what is RC4 and how it is going to be work. First one, block cipher design principles. So basically the block cipher, it mainly contains of specific number of rounds and keys. Means for generating ciphertext, we are producing here number of rounds and keys. So it is an encryption algorithm. Means encryption is nothing but converting plain text into the ciphertext. So it contains a fixed sized blocks of data. Usually it takes an 64 bits or 128 bits to produce the ciphertext process. In this block cipher, it also involves several important principles to ensure whole of security and the efficiency purpose of this algorithm. So there are 9 principles in the block cipher design principles. We are going to see one by one. First one is number of rounds. Means these 9 principles are working off based upon number of rounds and number of keys. First one is number of rounds. How they are going to perform. This number of rounds and design of functions, or these 9 principles, are going to perform of DES, AES, triple DES, multiple encryption process. These all algorithms are based upon these design principles only. So first one is number of rounds. In this number of rounds, we are using, for example of DES, we have an 16 rounds. Data encryption standard stands for the DES, and we are also having the DES formats of 16 rounds, that is K1 and so on up to K16 rounds. Means first round to 16 rounds we are having an DES format. So while in AES we have an 10 rounds, nothing but K1 and so on up to K10 process. They are having the 10 rounds of AES and 16 rounds of DES. Next, second one is design of the function, stands for F. So this is design of the function comes to the, it is a core part of the Fistel block cipher structure. This Fistel block cipher structure is the one also a round function. Fistel block cipher is the diagram of F which circulates the block Fistel block cipher structure. So it is a round function. So it basically uses in DES and AES functions. So it can be derived from the round function. It means that there are increasing level of complexity for the round function. Means to increase in complexity is nothing but an whatever the function of Fistel cipher block structure is performing in DES and AES, it sees the level of the rounds and level of the keys. The next third one is confusion and diffusion. Confusion is nothing but an to make it difficult for an attacker the relationship between the plain text and ciphertext. The purpose of the confusion is nothing but an to make it an difficult for an attacker between the plain text and the ciphertext. The next, diffusion process. Diffusion process is nothing but a small change in the plain text which is cause a significant change in also an ciphertext. So basically it changes in the ciphertext and also in the changes in plain text. That is known as diffusion process. Next one is key size. So basically we use the key size of 128 bits or 8 bits or 62 bits, 28 bits. We also use any of the format of the bits. So mostly used for the secure for most of the applications. And also see here point of should be a large enough to prevent brute force attacks. So brute force attacks is nothing but it is an trial and error method. Means the attacker is going to try number of passwords to get the original password of the message. Means he is going to try number of times to get the original password. That is known as an brute force attacks. The next one is key schedule process. In this key schedule process, mainly the keys used for encryption are independent and unpredictable formats. So basically we are going to see of a key schedule process while we are using any 64 bits or 128 bits or 8 bits, we are going to see an key schedule process. While we are using for encryption or any other decryption process, whether it is an independent or an unpredictable process. The next one is block size. So the basically of block size of DES or AES or any multiple encryption or triple DES formats we can use in the block size of 128 bits. So block size here is 128 bits to be secure for most of the applications. The next one is non-linearity process. Non-linearity process is used nothing but an, for example, here I am using the K1 process and so on up to K16 process. Here there will be an SBox format. Already have discussed in the previous video of AES, Advanced Encryption Standards. I already discussed the SBox format. So that is called as an SBox, which is vulnerable to the attacks, and it also exploits the linear properties of the ciphertext. The next one is avalanche effect. So avalanche effect is nothing but any changes modified in the plain text or any keys should be an significant changes also and ciphertext also. So basically the contains a small change in plain text or an key that equals to the ciphertext. That is known as an avalanche effect. The next one is ninth one, which is nothing but an security analysis. So basically the security analysis is used for various attacks such as differential cryptanalysis and linear cryptanalysis and brute force attacks. Cryptanalysis is also equal to the cryptology and cryptanalysis is equal to cryptography. So already I have discussed in the introduction to cryptography part, that is nothing but an cryptanalysis. So they are having two different types, differential and linear cryptanalysis, and also the brute force attacks. Brute force attacks already I have discussed here the what is meant by brute force attacks. So the cipher should also be tested for its resistance and to implementation attacks such as side channel attacks. So, and also see an example for the block cipher principles. Let's see here. So here having an key format, and here I am going to take an bit stream generation algorithm. Here also I am taking an same key of bit stream generation algorithm. By this both bit stream generation algorithms, we are using some of the keys KI process of cryptography bit stream. So here plain text, ciphertext and plain text. So plain text is nothing but an original message. Ciphertext is nothing but an whatever the encrypted of plain text, it is nothing but an ciphertext. So here having the number of bits for the plain text process. To do whole of the encryption algorithm, we are having the particular 128 bits or 64 bits or 8 bits or 128 bits. Of this whole 128, 64 bits, 8 bits. Of this taking of all bits, we are going to check here from plaintext PI process to the ciphertext CA process. So one by one process we are going to see of the example. Already we are seeing in the AES process. In the next video of next lecture, we can see in the DES process also. So the plaintext is going to be converted into the ciphertext by using only the encryption algorithm. That is known as an block cipher principles of an example. The next one is stream cipher. So stream cipher also will be an encrypted at a time, while in block cipher of using 128 bits are encrypted at a time, means at a single time. So here as input to pseudo random bit generator, and it produces a random 8-bit output. So 8-bit output will be an output process. Basically it input to an pseudo random bit generator process. So in this key stream, there will be size of 1 byte, that is equal to 1 byte equals to 8 bits. So the stream cipher are also fast because the encrypted data bit by bit or byte by byte. 1 byte equals to 8 bits. So whether it is going to be a fast because the encrypted data by either bit by bit or byte by byte. So they makes them efficient for encrypting large amounts of data quickly. Means they are making an efficient process and encrypting a large amount of data quickly in the stream cipher. So it also work for real-time communications. Real-time communications such as video or online gaming or streaming process, that is also an stream cipher. So both encryption and decryption also data will be processed as being it is transmitted in the stream cipher. There will be two types in the stream cipher. One is encryption process and another one is decryption process. So first we can see an encryption process. In this encryption process, we are going to see an plain text and key stream produces ciphertext. So here contains plain text and key stream. The whole contains ciphertext. Means by using these both, we need to get the ciphertext. And also see here the point of same key stream will be used for the decryption process also. So whatever we are going for the encryption process, we will do the same key stream for the decryption process also. So see here, the plain text will be undergone XOR operation with the key stream bit by bit and produces the ciphertext process. We are using here the XOR operation with the key stream bit by bit and produces the ciphertext. So what he has given here, plain text is given, key stream is given, and output of is nothing but an ciphertext. So plain text is nothing but this key stream, and we are getting an output of the ciphertext. By using an XOR operation, zero zero, 1 0, 0 1 and 1 1. So while we are doing the XOR operation, 0 0 will becomes 0, 1 0 becomes 1, 0 1 becomes 1 and 1 1 0 becomes 1. While we are substituting in this, 1 1 becomes 0 and 0 1 becomes 1, 0 0 becomes 0 and 1 0 becomes 1, 1 0 becomes 1 and 0 becomes 0 and 1 becomes 0 and 1 1 becomes 0. This is the example of the output of ciphertext. We need to do like this of the XOR operation. That is the XOR operation. So by doing this XOR operation, we will get an output of ciphertext. As the same process, we will do the decryption process also. So see here, for the decryption process, what we are here taking ciphertext and the key stream will use the original plain text format. So whatever we have used here, the plain text, now it is going to get the output of the plain text. Means it gives the output of original plain text. Original plain text is going for the happen. So here same key stream will be used for the encryption process. What we have seen the encryption process, the same key will be used for the decryption process. In the decryption process, the same key stream will be used for the encryption process. The ciphertext will undergo the same operation of using XOR operation. We need to perform of this whole example of this process, and we need to see an example. Same of the process, we need to take some of the example of ciphertext I have taken here, and key stream is also taken one of the value, and we have got the original plain text. What is the original plain text? 1 0 0 1 1 0 0 1. See in the previous slide, this is the original plain text. That is what the doing this process, do the example of decryption process. This is the output of the original plain text. Original plain text. This is the original plain text. The next topic is RC4. So basically RC4 stands for the reversed cipher 4, which was invented in the year of 1987. And it is a basically stream cipher. Stream cipher and block cipher is also discussed in the introduction to the cryptography and security. So go for the previous video. So it is also an stream cipher process which was invented in the year of 1987, and it stands for reversed cipher 4. So basically it is a stream cipher. It encrypts the data bytes by bits. 1 byte equals to 8 bits. So here it encrypts the data by bytes by bits. And also its speed and simplicity. RC4 is most extensively used stream cipher of all the stream ciphers. Means it is the most used stream cipher of all the stream ciphers. So see here the working of the RC4. How it is going to be an work for the encryption process. So it is a pseudo random bit generation. So and it also stream cipher can be used for encryption process bitwise exclusively, or whether it is going to combine it with the plain text. So the same procedure will be also used for the decryption process. Any of the process will be used for the encryption process and also the decryption process. So here also we are going to see as an exclusive OR operation, and it is also a symmetric operation. So by performing encryption process and decryption process also, we need to perform XOR operation. So by both this process, we need to give the XOR operation. While performing this XOR operation, we will have an output. So the cipher uses a basically secret internal state, that is which is divided into the two sections while to get the key stream. So one of the 256 available bytes is permitted and other 2 index pointers, that is what should be an each of 8 bits. So see here, the sample of key is generated, and also to go with an reversed cipher, and here we are using the key stream of pseudo random sequence. Any of the XOR operation we are going to see, that will give an ciphertext output. So here any message is sending of key speed, means K is sending some of the message and it gives the ciphertext, means by using the XOR operation we will get an output of ciphertext, that is known as working of RC4. RC4 is nothing but an reversed cipher 4. It was invented in the year of 1987. So in this video, we have discussed today's session is block cipher defined principles and what is meant by the stream cipher and what are those examples of both encryption and decryption process, and RC4, reversed cipher 4 of the algorithm. In the next session, we are going to discuss block cipher modes of the operation and what are some of the substitution techniques, Playfire, Caesar cipher and Hill cipher. These are the substitution techniques we will discuss in the next video. Thank you.